Okay, so here is your practice for isotopes. Right here, I want you to write down what is an isotope in your own words. So it's okay to refer back to the textbook or the lecture, but I want you to come up with your own explanation of what is an isotope. And then tell me when, for instance, we saw C14 and there was that 14 up above on the left and the 6 down below, what do those two numbers mean? What do they tell us about the structure of the isotope? And then how would you be able to tell the isotopes apart? What if you were looking at it at an atomic level, what would you see differently? So those should all be in your own words. Now the next section, I actually decided to make it a little easier for you than when I originally made this worksheet. So there's one specific change you need to pay attention to. In the row underneath atomic mass, I've changed that to stable or radioactive and removed for all four of those examples the request that you write down the positive charge, the negative charge, and the sum of the charge. I realize that's more complicated than we really would get into this year. If you take chemistry in future, that is something that level of complexity will happen there. All right, so what you need to do is you need to write down the name of the element up here. These are two different isotopes of the same element. So this is Cr, which I'm just going to tell you right now, it's chromium 58 and chromium 63. So here you would write down the number of protons, which should be the same regardless of the isotope, the number of neutrons, which is going to be different, and the number of electrons, which I'm going to let you decide and figure out if that's going to be the same or different. Now you can do this using the periodic table. You can do this using your own information. Or if you want to go online, you can research it that way as well. Give me the atomic number of chromium. You know what the element is because you've got the symbol right here. Tell me the atomic mass, which you can look up on the periodic table. And then based on the rules that I gave you in the last lecture, tell me whether that is going to be a stable or radioactive isotope. I'm going to give you a hint. You've got one of each. So if you can figure out which one is stable, you'll be able to figure out which one is radioactive. There are four elements you need to do this for. This one here with the C, this one here with the Na, and this one here with the Se. Good luck!